So here's a really cool trick. Let's say that we want our flames to wrap around our logs more. One way we can do this is by causing the logs themselves to cool down the temperature field. So check this out. If we go to our static object, physical, the last setting here is temperature, and we could set that to a negative value. Let's say -2. Now, if we go to our smoke object, we can turn on this temperature. Let's change this to infrared, and now begin changing our guide range to something negative. So we'll say -2. And what you'll find here is that, well, let's recache a few frames here. What you'll find is that the logs themselves are actually reducing the temperature around them. And whenever that happens, that's going to cause our areas of high temperature to wrap around those areas of low temperature. So you can kind of see it right here, where see how it wants to kind of hook around those logs like that? And that's a really cool way of emphasizing that effect. So check this out. We have a cross-section here of velocity streamers, which represents the direction in which velocity is going over time. And so we have this. This is without any sort of cooling whatsoever, and this is with the cooling. So here you can really see it curve around the log, and that slight motion that's bringing it inward is going to cause our flames to not just be flicking in a vertical direction, but also be going left and right a little bit. And that's going to cause a lot more character to that feathery edge of the flames when it's going out. And you can also see it just sort of puffs everything out, especially towards the bottom. So it takes our velocity, makes it more interesting, and that's a great thing. Now keep in mind that as we reduce the temperature right here, that's going to affect the way in which this flames tab is causing dissipation to the heat field. So as I was saying towards the beginning of the course, this is a situation where we just did something over here, turned down the temperature, and that's having a big impact on the way in which our flames dissipate. So what I'd like to do here is let's just bring our cooling field to maybe 0 to 4, and then bring this out so that we just dissipate a tad bit more in general. So now that we have that, let's see what that gives us. Okay, cool. I like how that's looking, and let's now move on to other things. So right now, it's a bit difficult to see what our flames are doing, and that's because we have a low heat value. So let's go over to our pyro imports, which is right here, and let's use a volume slice. If you remember back to Pyro 1, this is basically going to take a plane, put it through our volumes, and then read off the voxel values. Let's set that to heat, and then we're going to adjust this maximum here until we start clipping red. So right about there. That's 0.4, and if I go to our smoke object, and we go to the multi-field, emission, we have this emission color field, which is our heat. Let's set that to 0 to 4, or 0 to 0.4 right here. And now we can see this a lot better. Let's also go up to our emission scale and turn this up to about 60. So now it's really clear what we have going on. I'll get more into the shading of this all later, but for right now, we just want something that can give us a general idea of what our flames are doing. Next up, let's talk about the rest of these tabs. Honestly, most of the settings, most of the important settings are things that we've already covered, but these other tabs can make a very big difference for other simulations, and for this simulation, it can make some minor differences as well. So next we have smoke, and this is where density comes from. We have emit smoke, that's on, and we have this option to either create dense smoke or not create dense smoke. What I'll say about this is that if you have a combustion effect, which has a lot of smoke coming from it, then go ahead and create dense smoke. A campfire does not have dense smoke though, and so we don't need to turn that on. Essentially, it's going to change the way in which smoke is accumulated, and if you turn that on, you're just going to get a more pyroclastic look from the combustion. Next, we have the source, and that's asking you, where does smoke come from? We have heat or we have burn. And most of the time, I like doing heat, but I suppose if you had a lot of areas that are experiencing burn, or perhaps you have fire along the ground or something like that, then maybe you'll want to do burn. Most of the time, I like doing heat though. For the smoke amount, it sounds exactly like what it is. It's how much smoke gets added. And the next two parameters deal with when and how much smoke is emitted based on the heat values. So let me draw this out real quick, just so that we can see what's happening. So let's say our heat value, or let's say our heat cutoff here is 0.2. What that means is that as soon as the heat value reaches 0.2, let's say it's right here, we reach a value of 0.2, then that's when smoke is allowed to start spawning. So anything that's 0.2 or lower, so let's say this value is 0.1, we're able to realize the full smoke amounts. Okay? So these guys see the full smoke amount. This blend amount is a way of blending between the full value, which right now is 1, and everything that goes off to 0. And so with this blend amount to 0.2, what that is saying is that once we reach a value of, let's say, over here, 0.4, then that is when smoke completely cuts off. So it's kind of a way of saying, if we're 0.2 above this heat cutoff, then that's when smoke starts to emit. And then once we reach the heat cutoff, we're at full blast. Now you can set this blend amount negative as well, so that it blends in the other direction. But honestly, I would recommend just going with the positive direction like this. It's a little bit easier to think about that way. And so there you have it. Right now, since our maximum heat value is 0.4, that means that only the hottest areas of our sim are not allowed to emit any smoke. So we probably need to turn these values down a fair bit. If we only want smoke coming from the near cooler parts of the heat field, then we'll want to do something maybe like 0.05 and then a blend amount of about the same, 0.05. So now smoke is only going to come from pretty much the top portion of these flames. Let's also turn up the smoke amount so that we can really see it. Let's try something pretty big, like 20. And let's see what that does. Okay, and it's pretty difficult to see what this is, but let's change our lighting here. And now you can start to sort of see where that's happening. So we end up with something like that. Don't worry about getting this to an exact value, because in the shader, we can always turn down the amount of smoke that's visible in the render. So as long as you have enough smoke and that the smoke is coming from the areas that you like it to originate from, then you're good to go. Not so fun fact, there is the gas tab right here, and there's no mention of it in the user docs. So I'm going to go out on a limb here and say that here's what I think this means. This gas tab has to deal with how much of the flames and how much of the burn is contributing towards this gas released. So if the gas released is 1 and the burn contribution is 1, that means the burn field is contributing this full amount every single time, right? This flame contribution has to deal with the heat field, and what that is saying right now at 0.25 is that our heat field at every single step is emitting gas, but we're only emitting 0.25 of this value in gas at every single step. So anyway, that's my educated guess, but yeah, let's just leave that alone. I think that's cool. Let's wrap up the rest of these tabs in the next video.